This is a video related to section 3.3, again on the product and quotient rules. Okay. In a prior video we looked at the product rule, which was basically a rule telling you how to take the derivative of two functions that have been multiplied by each other. Okay. And we showed that the answer was the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. That is how you take the correct derivative of two functions being multiplied by each other. You may also see this written as f of x multiplied by g prime of x plus g of x times f prime of x. Or you may even see just written fg prime plus gf prime, which is also the same as gf prime plus fg prime. The trick is just to make sure that you have one function multiplied by the derivative of another plus, and then put the derivative on the function that wasn't in the first term and multiply that by the second function. Okay, and as an example here, just another example of a product rule, just to make sure we're all on the same page, we could have done the function f of x is x to the negative 2 multiplied by x cubed plus 4x minus 2. Now there are a couple of ways to approach this problem. This is, I'll show you method 1 of 3. I can think of 3 different ways to solve this. We'll do the first method first. So what I'm seeing here is a function f of x is a function g of x multiplied by h of x. Here's a function g. Here is the function h. Two functions being multiplied. Okay. G is the function x to the negative 2. H is the function x cubed plus 4x minus 2. Okay, so what we know here is that then always a good first step to go ahead and find g prime and h prime. Find the derivative separately. Okay, the derivative of g via the power rule is negative 2x to the negative 3, and h prime is equal to 3x squared plus 4. Okay, there's g prime and h prime. So the answer, according to the product rule, f prime of x is first times the derivative of the second plus the second times the derivative of the first. Okay? So g is equal to x to the negative 2, h prime is 3x squared plus 4, plus h is equal to x cubed plus 4x minus 2, and g prime is equal to negative 2x to the negative 3. Okay? And there's your answer for f prime of x. And it may help just to see what's going on here. It may help to simplify a little bit so we can see how all the methods that I'm going to show you are related. So the methods here, to simplify, you would just distribute the negative 2, so it would be 3x squared times x to the negative 2 plus 4x to the negative 2. Okay, that's distributing, plus distribute the negative 2x cubed, so it would be negative 2x to the negative 3, x to the third, plus, minus 8x times x to the negative 3, plus 4x to the negative 3. And now you get to use your properties of exponents. This is 3x to the 0 plus 4x to the negative 2 minus 2x to the 0 minus 8x to the negative 2, adding exponents, plus 4x to the negative 3. So that gives you 3 minus 2 is 1, 4x to the negative 2, and 8x to the negative 2 makes negative 4x to the negative 2 power plus 4x to the negative 3. And that's about the simplest we can get here, leaving it in the negative exponents. But if you don't like the negative exponents, you can make this 4x to the positive 2 plus plus 4 over x to the third. The negative exponents go to the denominator by losing their negative exponents. So there is the derivative f prime of x for this function. Okay. The second method, if you didn't want to use the product rule, you could have just, method 2 of 3, you could have just done some algebra first. You could have done algebra on the original function. The original function was x to the negative 2 multiplied by x cubed plus 4x minus 2. You could have distributed, done some algebra on the function first. That would have been x to the first power plus 4x to the negative 1 power minus 2x to the negative 2 power by distributing. And now the derivative of the function would have been just the derivative of x to the first plus 4 times the derivative x to the negative 1 minus 2 times the derivative of x to the negative 2. In which case you would have gotten the derivative of x would have been 1. The derivative of x to the negative 1 is negative 4 over x squared. The derivative of x to the negative 2 minus 2x to the negative 3 with 4 in front. There we go. Negative 2 times negative 2 is positive 4 x to the negative 3, and you get the same answer as we got from the first step method. Okay, so we've seen a product rule and then algebra help you, and we've used lots of power rule. Okay, so let's show the third and final step of this process. Okay, our function, let me just write it down here before I switch to a new page. You may want to do the same because we're probably out of room on your paper. We're going to do our third method, and that's going to bring in the quotient rule. Okay, so let's add a new page. Okay, and let's rewrite our function, and we'll call this method 3 of 3. Okay, and this method will be new to this video. It's called the quotient rule. Okay, and it's realizing that if we look at our function x to the negative 2 multiplied by x cubed plus 4x minus 2, that we can write this function as x cubed plus 4x minus 2, but then you can instead divide by x squared. Multiplying by x to the negative 2 is the same thing as dividing by x squared. And now we are seeing a function that is of the form g of x divided by h of x, two functions being divided by each other. And if you want to take the derivative of two functions divided by each other, okay, and you know the derivative of g and h separately, the quotient rule, okay, I'm going to state this without proof, is the lower function h times the derivative of the upper function minus, very important this minus sign, the upper function times the derivative of the lower function over the lower function multiplied by the lower function, otherwise known as low d high minus high d low divided by low times low, or low squared. Okay, so the lower function, the derivative of the upper function, the higher function, minus the high function, the one that's in the numerator, times the derivative of the lower function. And here we'll call this low squared, h of x times h of x. So here, this will give us our third way to compute the derivative, that if we're trying to take the derivative of a quotient of two functions, okay, we need to figure out what it is. But we know that h of x, also called our lower function, is x squared. G of x is what I'm calling g of x. It's the upper function. It is equal to x cubed plus 4x minus 2. So go ahead and you have the lower and the higher function. Just go ahead and compute the derivatives separately. We know we're going to need them to compute the derivative of the higher function. We'll get 3x squared plus 4. Okay. Now the only thing you need to do is remember the quotient rule formula to figure out how to combine these functions together. So the quotient rule says that I need to compute the lower function, x squared, times the derivative of the upper function, g prime, so that's 3x squared plus 4, minus the higher function, x cubed plus 4x minus 2, times the derivative of the lower function, 2x. I'm just following this formula right here and plugging in all the steps. And then I need to compute the lower function squared, so that's x squared squared. Okay. And if you do a little bit of simplifying, you will get 3x to the fourth plus 4x squared minus 2x to the fourth, distributing the 2x now, minus 8x squared plus 4x squared, and all that is divided by x to the fourth. Okay. So this long division, this division here, the numerator divided by x to the fourth, that means that every term gets divided by x to the fourth. Okay, go ahead and work this one out. And the reason I'm simplifying here is just to show how all these methods come together to give the same answer. The x to the fourth cancel, x to the fourth cancel, x to the fourth cancel, and you're left with 4 over x squared. X squareds cancel, and you're left with minus 8 over x squared over x squared. Ooh, let's see. Okay. Hold on just 1 second. Okay, I'm just 4x squared. Oh, and I forgot the minus. Oh, this should be minus 4x right there. Okay, 4x. I knew I was supposed to have a cube term, which is why I paused there. So we get 4 over x cubed. Okay, so 3 minus 2 is 1. 4 over x squared minus 8 over x squared is minus 4 over x squared plus 4 over x cubed, which is the same answer that we got before, the derivative of g of x divided by h of x. Okay, and there is another example worked out using the quotient rule formula. I will say that the formula is correct here, the derivative. Okay, the derivative with respect to x, high function over the lower function is low times the derivative of the higher function minus high times the derivative of the lower function over the lower function squared. This formula works. I haven't proven it like I did with the product rule, but it works because it gives the same answer from 2 other methods. So we know that this formula is what it needs to be. And that's the end of this video.